Hi, everyone. My name is Vladimir, and I'm here with Cameron and Jeremy to discuss our intermediate presentation on smart tracking technology for the disabled. Our main research question is how can smart tracking technologies, specifically a wearable, be designed and adapted to ensure accessibility and usability for individuals with physical restrictions such as paralysis, muscular dystrophy, or a missing limb, among others, to help facilitate effective health monitoring and management. Our health disparity topic deals with the usability of smart tracking technology for disabled users, and some of the main reasons why we found this topic to be important. First concerns inclusivity and equity, as those with physical disabilities can sometimes find this technology to be inaccessible due to issues with use, which can create a digital divide. The health component deals with the fact that smart tracking technologies have helped to improve the health of many through health monitoring. So any disparity in use can potentially affect healthy outcomes. And last is the quality of life, as tracking technologies and their connection to healthier lifestyles have been shown to improve lives, especially those who have truly embraced their functionality as an aspect of well-being. So why is this question important? Health monitoring disparities have become more prevalent as technologies have improved, potentially leaving those not catered to behind. Looking into this question can hopefully help to bridge the gap by helping to develop technologies that cater to their needs. Next deals with a component of underrepresentation, as historically disabled individuals have often been underrepresented and often overlooked in the design and development of technology. Last but not least is an ethical responsibility, since making sure that technologies are designed with accessibility in mind can be viewed as good practice to try to accommodate less targeted users. The reason why this research question is important to explore comes down to four main reasons. Customized solutions. As with research, we hope to gain knowledge to aid in creating customized technology that caters to the needs of disabled users, to gauge the prevalence of the problem, which can help us understand how widespread the problem is, and identifying existing solutions, as well as researching any current technology trends of tracking technologies. Regarding our existing research, we looked into accessibility challenges and found that they mostly dealt with issues with physical interactions, issues concerning accessibility of buttons, be it physical or digital, fine motor control issues, as well as frustration overload, often caused by struggle with complex user interfaces. Regarding the prevalence of the problem, we found that 14% of participants with disabilities were trackable device users, compared to 33% of users without disabilities. Individuals with disabilities were less likely to use versions of tracking technologies, often based on usability issues. 83% of clinical trials and 95% of NIH-funded research involved consumer activity monitors use tracking technologies. Disabled users can be left out of studies if accessibility issues are not resolved. In regards to existing solutions, we found mostly dealt with helping those who are disabled through aspects of navigation, specifically head tracking technology, facial recognition movement for navigation, eye movement recognition, as well as some gesture recognition. Technical trends found currently deal with Fitbit, Jawbone, wearable fitness bracelets, and other types of wearables, such as Apple Watch, among others. In terms of research gap, design was one issue, with no real user-centered design frameworks often found associated with disabled population. There were difficulties finding outcome studies, which could show some long-term user experience of tracking technologies and outcomes over time. There were also difficulties in finding disabled representation, as existing research concentrated on conditions such as paralysis, while overlooking other less common physical disabilities.
So a couple of our key informant interview participants, they include our friends, family, and most importantly, we also interviewed some professionals as well. Among these key informants include social workers. We also interviewed an orthopedic medical professional, stem cell researcher, a grandmother of ours with the limited arm mobility, some paralysis patients, partial paralysis patients, and also a family friend who also has a missing limb. A couple of our findings and summaries from these key informant interviews include that those who dealt with disabilities were actually less likely to use tracking technology when compared to their more able-bodied counterparts. And this would actually require catering this technology for individuals to be able to use the interface and navigate the technology regardless of disability, since there are a couple types of different disabilities out there. Some of the issues for a disabled person's use of tracking technology also came from those who have not had to live with disabilities prior. So this could mean that maybe they got in an accident or something unfortunate happened to them, and they got a new disability. So individuals with new physical injuries that are limited mobility could also become frustrated in using technology that requires full dexterity. A couple more of our findings and summaries. Some people have the desire to be included. So some viewed that tracking technology as not being meant for them and would be more inclined to use these devices if the technology was perhaps more catered towards accepting and incorporating their disability. So some of the issues stem from limitations associated with some types of notifications that they would get on their devices. And a couple of the issues as well are some things to tackle on is the one arm use, limited arm use, some dexterity issues, and limited sensitivity to current notification settings. Now, some also excluded themselves out of the interview. So some interviewees expressed feelings of frustration and exclusion due to their limited ability to use the tracking technology. Some of them were also unaware of technological trends as well. So many in the field were not aware of these trends, and they focused more on popular technology as a basis for trends. And last but not least, disabled friends and relatives were also inclined to use smart wearable devices to track their health if their particular disability did not hinder their use. So a couple of confirmation and conflicts here that we could gather together and piece together from these key informant interviews as well as our literature review. So one conflict that we have is that the initial assumption was that most individuals were privy to the tracking technologies available, and some interviews were actually not aware and some were not keen to using said technology. The confirmation that we have is that there is an exclusionary problem that is faced by individuals with physical disabilities. There was a consensus that the technology available was not made with their limitations in mind, and we could find this from our key informant interviews along with our literature review. On top of that, we also want to add that another confirmation is that individuals with physical disabilities were able to utilize smart wearable devices to track their daily activities, but of course with unforeseen difficulties that come to mind. And last but not least, a conflict that we have is that smart wearable devices can track vital signs such as steps, heart rates, pulse, which then can be used and reported back to healthcare professionals. But there was sometimes no motivation to continue using these devices that are not catered to the users anyways, so overtime use of devices eventually stopped. A couple of the design requirements that we wanted to keep in mind was the interface navigation, as we mentioned earlier. It was basically issues with interface navigations based on physical disability of users. This was definitely an issue that was relayed after the initial literature reviews and when interviews were completed. So this essentially prompts us to design our design to incorporate different forms of navigation to accommodate physically disabled users. Some of our ideas would include single button navigation, which is essentially ideal for users with dexterity problems such as limited hand or finger mobility. This can definitely help minimize the risk of unintentional inputs by the user if we have a lot of buttons on our devices. Another one is gesture navigation. So this is for people who are missing appendages or have limited limb mobility. They no longer need to rely on physical buttons or touchscreens, but instead they can perform some gestures or motions to rather interact with the device and control the interface. Another design requirement that we have is also adaptive feedback that adjusted based on the physical disability of the user. So for example, temperature change. If a user has paralysis due to spinal injuries, they tend to have lower body temperature, and they can be numb to certain stimuli, but be sensitive to temperature change. So we can make our device have some type of temperature change. And on top of that, we also have pressure application. So users can definitely set the intensity, pattern, or location of pressure notifications to ensure they're both effective and comfortable. So this level of customization definitely can cater to a wider range of users with disabilities as well. A couple of the design alternatives we thought about was the full navigation based on head tilt. So it incorporates sensors that detects head movements such as accelerometers and gyroscopes. And these sensors would track the orientation and tilting of the user's head. And head tilts and rotations could be mapped to specific actions or commands, but we didn't go with this because it may cause problems with the users tilting their head and causing them a lot of movement when perhaps they're not able to move their head a certain way. And the second one is the projection screen real estate adjustment. So you can use projection technology that can display information based on nearby surfaces from wearable tracking technology, expanding the screen size beyond a physical device, and users can interact with the projected interface. But then there would be some type of issue with this where users might have a hard time finding a flat surface or even angling the device so the projection could come out correctly.
And next, we will look at our storyboards and then our prototypes, key features, and innovations. So when firstly, we have introduced a highly customizable interface. This means users can adjust every aspect of their interface from the layout to the size of the buttons to accommodate their specific mobility and accessibility needs. For instance, those with limited hand movement can opt for larger buttons or intuitive gestures, enhancing their interaction with the device. Secondly, we've implemented gesture control personalization. This is where users aren't limited to a one-size-fits-all approach. They can redefine gesture control to align with their physical capabilities. And lastly, our device includes a variety of assistive components. Haptic feedback is just one of them, and these features just provide an inclusive experience, ensuring that users with different sensory and motor needs can navigate the technology confidently. Next, we move over to our storyboards, which we have three of them. For the first one, this is Mark, and due to his disability, he uses full voice navigation to help use his wearable tracking device. Hey, he's prompted and it says, hey, please start checking your heart rate. From there, you can see in our third frame, he's checking his heart rate. There, can you give me the heart rate results um, of the heart rate check? And at the last storyboard, you can see the results of the heart rate check. For our second storyboard, this is Tracy, and she has paralysis. She's below in her left hand. Tracy receives an alarm to take her medicine, but the vibration is not felt due to her paralysis. If the notification is not checked, the device changes from vibration to temperature change to help notify users. Oh, my hand is getting warm. I must have a notification. And then lastly, we'll move over to our third storyboard. Here we can see from our initial setup, Jake, he's setting up his new smart tracking watch. The watch features voice activated setup instructions, making it easy for him to configure settings without the need for intricate finger movements. Next, he's customizing the interface. You can see from our third frame, the watch guides the user through a series of tutorials to record personalized gestures that match their mobility capabilities. From our fourth frame, this is where our adaptive feedback comes in. The smartwatch not only monitors Jake's health vitals, but also provides adaptive feedback through temperature change. Next, we can see that social connectivity aspect of it, where the user utilizes the watch voice to text feature to send messages to friends and family. And then lastly, we have that emergency assistance. In case of an emergency, the user can activate the SOH feature with the preset gesture or voice command. Lastly, we will move on to why we chose these different designs. Our smart tracking technology is engineered with the user at the heart of its design, ensuring an improved experience that is both accessible and empowering. It is carefully crafted to communicate effectively and provide feedback in a way that minimizes errors and enhancing the overall interaction with the device. So some of the key features, as you can see, is improved user experience, ease of interaction, where the features such as personalized gesture control allow users to interact with traditional touch-based interactions, which can be difficult for some. And then empowerment. These designs offer a range of customization options, enabling users to tailor their device setup for maximum comfort and efficiency. And lastly, are all of our outstanding work. You can see our two main points is continued research into the topic to try to mitigate any research gaps, and lastly, interviews with other possible informants to gain just a better perspective of potential issues, as well as to aid with any design adjustments needed. And just from all three of us, we just want to say thank you for this presentation.